Hi everyone, welcome to our 7th training video. In the prior videos we showed how we can download and run the libraries from Adib Robotics on various operating systems. In this video we're going to be only using Linux, but it's pretty much the same on other OSs. And we're going to be using the robot controller, and we're going to delve deeper into the motion control APIs as well as the EtherCAD APIs. So I have a freshly installed Adib Robotics controller release for Linux here, and I'm looking at I have the config file, the sample config file, and the demo script opened over here. So first I'm going to, as usual, I'm going to launch the controller software server for the Delta config. Please make sure to use sudo, otherwise you may get weird errors, because your system otherwise would not have access, would not have privileges to make changes to the Ethernet driver and things like that. Now I'm over on this side. I'm inside the Python scripts folder, and I'm going to launch Python as a terminal, and now I'm going to import from arc import star. So currently I'm inside this folder, and I'm importing this arc.py script. This is a convenience script provided by Adib Robotics that has the mechanism to request and pull response of various REST APIs. So if you look at the manual, you will see that every API is divided into two parts. You have a post that initiates the request, and then a get that gets you the response if the command has completed. Because all these APIs take some time to execute, and the server can't hang, so you have to initiate the post and then you poll for the response. If you look at this API, it's a helper provided by many of these APIs here, and it will initiate the command and then poll for the done flag in the response, and it would check for error codes. If there's any error codes, it would print it out. The documentation shows talks about how the REST API works, but it doesn't contain the Python helper APIs yet. But it's quite simple. For example, initializing the network is done as so. Servoing on an axis is done as such. You can review these APIs in detail in the Python code. So I'm going to import all the information I have in the arc.py script. You want to make sure that you run this after you run the server, because this actually talks to the server. So that's that. It ran get config because some helper APIs here, like especially the auto run, they use the config that's read from the server. So now I'm going to do something really simple, such as exit. I need to initialize the network, the controller. So initializing the controller will end up initializing the network and initializing the axes, and entering op EtherCAT state. Potentially you could do each one of these, but this is more convenient. So when I run this, you could see that it scanned the network, it entered op EtherCAT state, it found this slave. So everything seems to be functioning properly. It warns me when you initialize the axes and they can't all be found on the network. For example, this axis is configured as a physical axis because its slave index is actually set. If you want it to be a virtual axis, you would comment it out as such. So the first axis is actually configured as a virtual axis, so I'm going to change that. Unfortunately, we don't support reinitializing the controller after changes to the configuration file. So you have to quit here and then restart the server. This is something that we would like to support in the future, reinitializing the controller after changes to the config file. Anyway, so I will relaunch Python, and I'm going to import everything from Arc, and I'm going to initialize the controller, and it's an op state. Now our first axis is usable. I'm going to now do something as simple as axis servo on. So now I need to give it the axis index. I'm going to give it 0. You can hear some humming, so it did actually servo on. I'm going to servo off now, and now the humming is gone. If it's servoed on, of course, you won't be able to turn the axis. There's some like resistance there. Potentially you could servo on the group. So group servo on. And if we look at the group servo on API, and according to the config file, all the axes, axes 0, 1, 2, 3 are part of the group, and the group type is Delta robot. If you look at the group servo on API in the Arc script, there's two versions of it. There's the cycle servo on, which follows the configuration provided for cycling. This is for auto run, which is a convenience way to specify some configuration and to run the robot without programming. You either configure it to pick up from a conveyor and drop into a container, or vice versa. Now, if we go back to the group servo on API, there's the version that uses _cycle, or there's the version that uses the group index directly. The group index is actually optional. So a lot of APIs that use, all the APIs that use parts, containers, conveyors, or groups have their indices as optional, because the vast majority of use cases will have only one group and one conveyor, one container, and one part. If you're using multiple conveyors, then you will need to specify the index. So if we look at the group servo on API, I could run it without passing in an index, and again the motor is humming. If I servo off, and I could tell it the group index is 0, I get that. If I try to servo on a group that does not exist, I should be getting a invalid group index error code. If you search for this in the documentation that you can download, that you can get from our downloads page, you'll see that this is an invalid group index. Similarly, if I had used an invalid axis index. Let's say I try to servo off axis 7. I get an invalid axis index, 1002. So now let's run some motion. So you could either command axis or group motion. I'm going to start with axis motion. So I'm going to servo on axis 0. And axes commands do not have defaults for the axis index because the vast majority of the time you will have more than one axis. So now I'm going to do axis, move, position, and the default units are in degrees. Potentially we could read the position just to know what position we're at. So axis get current pause is the API. So we're at 0.025 degrees, which is basically 0. If we try to do axis, move, position, and we ask it to go to, let's say, 90 degrees. So the default units are degrees, and counterclockwise is positive. So we should expect the zip tie here to be horizontal towards the left. So when I try to run that, it complained that I did not provide the axis index. So that's understandable. Axis index is 0. So it did not move to plus 90 degrees, and it's because I forgot about something. The gear ratio for the first axis is set to 28. So it's going to be doing 28 divided by 4, because 90 degrees is 1/4 of a revolution, which is, I guess, 28 divided by 4 is 7. So it probably just did 7 revolutions. I'm going to, for simplicity, I'm going to stop this. I'm going to change the gear ratio to 1, going to relaunch, and over here, I think it's safer to quit and relaunch. So I need to initialize the controller initially. Actually, I need to import. So now I have access to all the convenience APIs. Otherwise, I would have to be doing HTTP requests and pulls. So now I need to initialize the network. Let's say I forget to, if I forget to, I need to initialize the controller. If I forget to initialize the controller and I try to do axis commands, it's going to give me an invalid axis because the axis doesn't exist in the system yet. So that's expected. Init controller. Fortunately, there's tab completion, so you can see that this only exited when this completed on the server side. It's because this is actually the longest command in the entire Python scripting library, and we have to pull until it completes. So now I'm going to servo on axis 0, and I'm going to command the axis to move to position 0. We're probably not at 0 because the motor moved before. So it wants the axis index, which I forgot for a second time. Now I got a motion alarm because we've exceeded the joint limits on axis 0. This is because according to the config, this is configured as one of the joints on the motor for one of the joints on the Delta robot, and you don't want any of the joints of the Delta robot exceeding this range. So what I'll need to do now is right now we basically started the motor in a position that's outside its limits. The easiest way to fix this is I've configured my motor as an incremental motor. So if I reset the power to if I reset the power to my servo drive, the position will go back to 0, which I'm doing right now. And then I just have to relaunch everything. So I've re-imported the Python helper APIs. I'm going to initialize the controller, and now I'm going to attempt to move to position 90 plus 90 degrees. Oh, sorry, I need to servo on first. So now you could hear the motor humming, so it's servoed on. And now I'm going to try to do the motion. Axis move position. The first argument is the position I want to go to in degrees. And this is a floating point number. And I need to give it the axis index. So you can see it turned to 90 degrees. Now, I did not set the velocity and acceleration and deceleration and jerk limits for the axis. By default, they're configured as 1% of the maximum possible value. Potentially, I can do set speed percent to be something as 10%. So it should be running 10 times faster now. So for axis index 0, I want to set the velocity and move profile limits to 10% of their maximum possible value. So that worked, and I'm going to try to go back to position 0 now. It should move much faster. So you could see that it moved much faster. If we try to move to minus 90, then it will turn the other way around. It looks like, yes, we've exceeded the position limits because only minus 45 is allowed, so we can do minus 45. So that worked. So now you could see how we could do some servo on, servo off, and some simple position commands. We'll get into more details in our next video. Thank you all for watching, and we'll see you next time.